All right, today we're going to be talking about area of a triangle, and triangles are shapes that have three straight sides that are closed. So here we have our star chart formula where we have the area of the triangle equals 1/2 times the base times height. And this base times height is what we've been using with the area of the rectangle and the parallelogram. In fact, if I were to copy this rectangle and flip it and then set it up there side by side, what I'm going to get is a parallelogram. So that's the reason why we can do half of that formula, is because a triangle, and if you think about it, any rectangular shape you draw, if you cut in half, what do you get? I get a triangle. So that's why we can use the 1/2 multiplied by. So when we're looking at base times height, we need to remember that base times height always makes a right. So that's just such an important concept. And just like with the parallelogram, sometimes that height will be dropped inside the shape and sometimes they'll be dropped outside the shape. So when we have this multiplying by 1/2, we need to remember that that is the same thing as dividing by 2. So that's because the properties are inverse and their digits are reciprocals. So if we say that something is multiplied by 1/2, we can also think of it as divided by 2. So sometimes you may see this written as A equals BH divided by 2, because multiplying by 1/2 is the same thing as dividing by 2. But we need to remember that algebraic equations are written in terms of multiplication. So that gets complicated sometimes when you know that normally what you would do is divide. So if you know you're dividing by a number, you can multiply by the reciprocal. And that's just one of those things we build up as we go through this. But you'll see formulas written this way. But this is equivalent right here, BH divided by 2. And sometimes it's easier to think about dividing a number by 2 than multiplying it by 1/2. But these are equivalent expressions. All right, we're going to do some practice problems. And I added this, you might want to write it down. Base and height make a right angle. We always need to keep that in mind on what we're doing and when we're looking at our triangles. So finding out the base is pretty easy. We tend to look at the length that it's sitting on. It doesn't always have to be that, but in this case, that's what we're going to use, because our height is going to be creating that perpendicular right angle. And so that lets us know that this is going to be extra information. If our right angle was going this way toward it, if it was going this way toward it, then we would use that piece. But since our height is dropping to this one, this is our base. So our base is 6 meters. Our height is 4 meters, and we're solving for the area. We don't know that one. And again, that is extra information. So they can spin it up on you, but you're looking for that height, and so that helps you identify what the base is. So we always start with the formula, the 1/2 base times height. So we start substituting in what we know. We know that it's 1/2 of 6 times 4. And when I multiply this, I can choose whatever order because of the commutative property. I could choose, but in this case, I'm going to go ahead and do my whole numbers first. So I have 1/2 times 6 times 4 is 24. And then I need to multiply by 1/2. And you need to remember, this is the same thing as 24 divided by 2. Those are equivalent statements. So half of 12, or 24 divided by 2, would be 12 meters squared, which is the area of my triangle. Most people, when they do this, they forget to divide by that 1/2. So here, let's look. And the first thing we want to identify is our height. There is that perpendicular line that's coming down that lets us know that this is our base. So we need these two pieces of numbers, and what we need to do with this one is cross it out. We don't need that one for this problem. So we have our base, our height, and our area, and we're going to label what we know. It's 2 meters, 1.5 meters, and then we're searching for our area. Always start with the formula from the star chart, area equals 1/2 of my base times height. And if you notice, I went ahead and just put parentheses there. You can, they're not showing multiplication with anything but just button everything up together, but if you need to see it, you can. So we have 1/2 of 2 times 1.5. And so I have 1/2 of 2 times 1.5 would be 3. And so to make that a fraction, I'm going to put it over 1. I get 3 over 2, which simplifies down to 1.5. And we would have meters squared for the area of my triangle. So remember, the commutative property lets me multiply in whatever order I want. I could have done 1/2 times 2 and gotten 1 times 1.5 and would have gotten there sooner. That's totally up to you. Just tend to stay in whatever format they give you. So like here they gave you decimals, here they're going to give us fractions. So we look for our height. Our height is going to be this one. And our base will be that length right there. So we're going to be solving for the area. So we start out writing what we know. My base is 14 1/2 inches. My height is 12 3/4 inches. And my area is my unknown. So one of the things I'm going to do after I write my original formula from the star chart is I'm going to go ahead and convert those fractions, the mixed numbers, into improper fractions. I'm going to do that aside before I put it in place. I think it'll just be easier to take care of that. So I'm going to come over here to the side, and I'm going to have 14 1/2. So to get it into be a mixed number, from a mixed number to improper fraction, we multiply the denominator times the whole number, which would give me 28, and then we add that 1 into it, which would be 29. So when I start substituting it in, I can go ahead and put it in as 29 seconds. So now I need to change this next one, which is 12 3/4. I need to change that into an improper fraction. The denominator will always be the same. 4 times 12 would be 48, plus the 3 would be 51. So I'm going to have 51 over 4. Now, I like this because it's 1 times 29 times 51. And so I need to do my numerators times my numerators, and then my denominators times my denominators. So I'm going to go ahead and start with my denominator first. And I'm going to do these two first. 2 times 2 is 4. 4 times 4 is what? 16. Okay, so I can't do 29 times 51 in my head, so I need to do a little problem. I like to put 51 on the bottom because it has that 1 that lets me do that first row really quick. And then I have 45. And so 5 times 2 plus 4 would be 14. So I have 114.79 divided by 16. So to simplify that improper fraction, I need to do a division problem. 14.79 divided by 16. I know 16 won't go into 14, but it will go into 147, and it's almost 10 times it. So I'm going to try 9. 9 times that would be 54. And so it would be, yep, good guess, 39. 3 times 16 would be in the 40s, so it's going to be 2 times. And that would be 32. And I have 7. And so I just need to stop there because the area of my shape is 92. There's my number that's on top of the line. 7, that's my remainder. 16ths, that's my divisor. Inches squared. Boom. All right, these two are going to mix it up a little bit for you. If you notice, they give you the area. What? They give you the area, and they give you a base, but what they don't give you is the height, or, there's a missing piece. So, but we solve it the same way. We start with what we know. Here I'm going to put the base, height, area. And so in this case, my base here is 14 meters. I don't know what my height is, but I know my area is 42 meters square. So this is where that formula comes real handy. We got to figure it in correctly. So 1/2 of base times height. So my area number goes on this side of the equal sign. 42 equals 1/2, and I know what my base is. That is 14, but I leave my h, the variable, because I don't know what it is. So this is like when we did the one-step equations. We have to isolate the variable. So the first thing we have to do is I need to do 1/2 of 14. Well, remember, multiplying by 1/2 is the same thing as dividing by 2. So I have 7h. Now I need to get that variable h by itself. That variable needs to be by itself, so the opposite, the inverse of multiplication, is division. So to get it by itself, I need to divide by that number, and I have to do it to both sides. So these two cross out. 7 divided by 7 would just leave me with 1h. 42 divided by 7 would leave me with 6. So here I can say that my height is equal to 6 meters. And it's not squared because it's not talking about the area. So here it gives it to you in word description. It says the triangle base is 15 meters. The triangle area is 37.5 meters, and that really should be a tiny 2. It should be right up there. So let's start out what we know. We need to find our base, our height, our area. We label what we know. I know my base is 15 meters. I don't know what my height is, but I know what my area is equal to 37.5 meters squared. I know my formula is the area is equal to 1/2 of my base times height. So now I start substituting in, what I do know versus what I need to find out. So when we do this, this is where people have problems. This goes in place of the area. 37.5 equals 1/2 of 15 times h. So here we have 37.5 equals, and I need to do a little division problem. 15 divided by 2 would be 7.5. Okay, so I have 7.5 h. To get rid of it and isolate the variable, I need to divide both sides by 7.5. Do you see how these problems are pulling everything that we've learned together? We have rational number divisions, we have isolating the variable, and we now have shapes. So let's do the division. 7.5 divided into 37.5. I can't have a decimal here, so I have to move it one space. If I do it to one side, I have to do it to the other. So let's do some estimation here. I know that 7 times 5 is 35, so I'm going to try with 5. And we have 5, 2, 35, 37, and boom, right on it, no remainder. So my height is equal to 5 meters. It's not squared, it's not area. There we go.